Hello and welcome. The purpose of this video is to go over this idea of what is a mole. By the end of the video, I'm hoping you'll conceptually understand what a mole is and have a sense of where we use moles in chemistry, or at least a few of the applications. So thanks for watching. Let's get right into it. Moles are units of measurement in chemistry. I'm going to ask you to pause the video for a second and try to think of some other units of measurement that you have already seen in chemistry class. I'm just going to keep moving, but you should pause and think of some of your own ideas here. So one unit you may have come up with was grams. Grams, of course, are used to measure mass. Maybe you also thought about milliliters. Milliliters are used to measure volume. And maybe you thought about seconds. Seconds are used to measure time. So just like all these other units we've seen, we can also measure moles. Moles is not one that we can so easily measure with a tool in the lab, but it's really, really helpful for counting small things. And when I say small, I mean like submicroscopic atoms, molecules, ions, that kind of small. All right, so moles are kind of similar to either a pair or a dozen. Whenever I say a pair, I mean two things, and I could have a pair of socks or a pair of chopsticks or a pair of really anything. It doesn't matter what the thing is. If I say pair, I'm always going to mean two. It's the same with dozen. I could have a dozen roses or a dozen pieces of chocolate or a dozen of anything. Anytime I say dozen, I mean 12 things. A mole is the same. It's 6.02 times 10 to the negative 23rd things. It's just a really big number of things, but just like pair or dozen, one mole means this many things, this giant number of things. So, extending this analogy, we can count individual things using other units like pairs, dozens, or today we'll learn about moles. Let's think about how we might count individual things using pairs, for example. So I have some socks here, and I'm asking how many pairs of socks are shown. Well, I have 8 pairs of socks, which means 16 individual socks. So I used the unit pairs to count an individual thing. Same thing here. I have 1, 2, 3, 4, 5 pairs of chopsticks. So I used the unit pairs to count an individual thing. I could also use dozens. I have 12 eggs, so I'm using dozen to count an individual thing. And I could even have part of a dozen, for example. So here I have 18 donuts. 18 donuts would be 12 donuts plus half a dozen donuts, which is 18 donuts, or 1.5 dozen. So I'm seeing that I can count individual things using other units, pairs, dozens, and now we'll take a look at moles. If this idea right here is unclear, pause the video for a moment and get yourself caught up. Otherwise, we'll keep moving. Moles are units that measure anything, just like pairs being 2 things, 1 dozen being 12 things. 1 mole is 6.02 times 10 to the 23rd things. That's this giant number here, 602 sextillion. So it's way bigger than a pair or a dozen, but it's still just letting us count to a giant number of things. And generally, those things will be atoms, ions, molecules, these really small things we've learned about in chemistry class. For example, you could have a mole of water molecules. You would have 602 sextillion molecules. So if you picture, here's a couple molecules, and we're going to extend that to 602 sextillion. Instead of writing out this giant number, I can just call this a mole. You could also have 2 moles of something. So for example, here I have 2 moles of gold atoms. Obviously, I'm not showing all 2 moles, but I would show that as 2 times 6.02 times 10 to the 23rd, or 1.2 times 10 to the 24th gold atoms. But instead of writing out this giant inconvenient number, I can also just call this 2 moles. Just like 24 gold atoms would be 2 dozen atoms, 1.2 times 10 to the 24 gold atoms would be 2 moles. All right, let's pause for a second and look at what that might look like in the calculator and how I'd put this giant number in. So if I'm going to enter 6.02 times 10 to the 23rd, the easiest way to do that is actually using the second EE button that you find on your calculator. That E button means 6.02 times 10 to the 23rd. And for example, I can multiply that by 2 and get this answer that I just showed you, 1.204 E24. That's going to be the same thing as the answer that we were just going over. Excuse me, let me pull up the PDF. There we go. So in order to put 6.02 times 10 to the 23rd into my calculator, I used 6.02E23, and that got me this 1.20 times 10 to the 24 number. Let me show that to you again in a TI-84 calculator. So in a TI-84, again, you're going to use second EE, and second EE shows you 10. So second E, for example, 6.02 times 10 to the 23rd. In the calculator, it would be 6.02E23, as you can see right here. So I'm going to press second first, then the comma button to force it to show E. And then when it gives me an answer using E, that just means times 10 to the power of whatever's after the E. So 10 to the power of 24. Giant number is a little hard to manage, but that second E trick makes it a little easier. So why do we care? Why are we doing all this work around moles? Why would moles be a useful unit in science? I encourage you to actually pause the video and think about this before we move on. So I ask you to remember from the beginning of the year, mole atoms are very small, very, 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 very small. We know if you blew up all the atoms in a grapefruit to the size of the blueberry, the grapefruit becomes the size of the entire Earth. That means each atom is teeny, teeny, tiny, tiny, too small for us to imagine. So that means in anything I have, there's many, many, many atoms. There's always going to be a ton of atoms, even in just a small sample of something. So even in a small amount of matter, there's always going to be a lot of atoms and molecules because each atom is so small. That means that it's really helpful if I can count, not using giant numbers. So for example, on a cotton t-shirt, this is the number of cotton molecules we would find just in one t-shirt. Is this a convenient number to be using and thinking about? Not really. In a Visco Girls Hydro Flask, here's about how many water molecules we would find. Again, not the most convenient number to count the molecules in my Hydro Flask. Or in an apple, here's the number of atoms that I might find just in one apple. So imagine the size of an apple. Somehow this number of atoms fits inside the apple. So moles allow us to express the amount of matter without using those crazy big numbers. So for example, in this t-shirt, remember there were all of these cotton molecules? Well, that translates to 0.797 moles. This is a much more manageable number. Similarly, in the Hydro Flask, 65.8 moles, again, kind of a big number, but way more manageable than this monstrosity. And then finally, in the Apple t-shirt, there's 1,661 moles. So again, a big number, but way more manageable than this number. So you'll notice that as soon as I put things in terms of moles, the numbers get easier to deal with and they're easier to compare. Before, all I could say was, oh, I had a bunch of big numbers. Now I can say, wow, there's way more atoms in the apple than the molecules of water, than the molecules of cotton. So the moles allow us to express the amount of matter without using very large numbers and to easily compare amounts between different measurements. All right, at this point, you should be ready to work on your practice. Thank you so much for watching. Let your teacher know what questions you have. Excellent work.